So starting right now, we're comparing and interpreting rates, as well as reading some graphs and finding slopes of graphs and putting it all together. You can represent rates in several ways. Try to choose the way that suits your purpose best. To compare rates, write them with the same units, so the second terms have the same value, or write them as unit rates in which the second terms are equal to 1. In a graph of the relationship between two quantities, the slope of a line segment represents the average rate of change for these quantities. The slope of the line segment that represents the rate of change is the unit rate. Okay. We're going to also work on our converting skills a little bit. Stuff that you would do in chemistry, you do in physics, and you will also want to be able to do a little bit of it in math. So for example, you go into the grocery store and you want to compare prices of something. So you've got a 2-liter of Pepsi for $1.99. Okay, so we have 2 liters. For $1.99, and then you have six cans, 351 milliliter cans, so 6 351 milliliter cans, and that might cost $2.19. So we want to find out what is the best deal. So that's kind of what we're looking at today, is how do we represent the best case scenario, the best deal. All right. So somebody suggested to me how I would check and see which is the best deal here.
Change the milliliters to liters.
Change the milliliters to liters. Okay. So how do I do that?
Divide by 1,000.
Okay. So what is the ratio then of liters to milliliters?
0.35 ratio.
1 liter is 1,000 milliliters.
1 liter is 1,000 milliliters. Okay, very good. So then it's 0.351 liters right now. Okay, multiply that by 6. What do we get?
2.106.
2.106 liters. Okay, so we have slightly more than 2 liters, but does that help us find out which is the better deal?
No, you divide it by the cost, and then you divide the 2 by 190, right?
So so what are you suggesting here?
You take 2.106 divided by the cost, which is 219.
Okay, so I'm going to divide that by 219.
And then you're going to take your.
Okay, so what is that? Hold on, let's finish this.
0.9616.
So in terms of my units then, so I've got would you say 9616 is going to be what? No, I don't think so.
Liters per dollar.
Liters per $1, right? Okay. So that's one way in which we can do it. We can find out what it is. So then we got to do the same thing here. So now I did take $1.99, right? And divide it into 2. And what do I get?
0.995.
No, we did it backwards.
1.005.
Did it backwards, right?
1.005.
1.005?
Yeah.
Liters per $1, right? Okay, so which is the better deal?
2 liters.
The 2 liter? Because what?
Because it has to be more liter per your dollar.
More liters per my $1. Okay, so that's one way we could have done. What is the second way in which we could have done?
You could have found how much money is 1 liter.
Absolutely. We could have found out the cost of 1 liter of each one, right? So we take $1.99, and you actually had it. So it was $1.99 divided by 2 liters was $0.995 per 1 liter, and what would it be over here? So take 219 and divide it by 2.063. 1.039 dollars per 1 liter. Okay, so financially speaking, that's the better deal, correct? Okay, but one of the other things that you have to look at, maybe not so much in Pepsi, maybe it is in Pepsi, but let's say you're, looking at milk, okay, something that can go bad after a little while, right? Like Pepsi, I guess theoretically can, but not only do we have to take into account the cost per the unit, we also want to take into account how we're going to use it. Okay, does it make sense to buy something in bulk? All right, our favorite bulk store is obviously Costco. Everything is in bulk there. But you're not going to want to buy bulk if you want to buy something that could spoil after a while, because you're probably not going to get to it. So things like fruits, vegetables, things that you can't freeze, all right, probably not the best thing to buy in bulk, unless you got a big family and you know that that's going to get eaten or whatever. So this is the way in which we want to do it. You want to either do it by the cost per the unit, or you take the unit and find out how much the unit's going to cost you for $1, 1 cent, whatever it is that you want to do. And that's what we're doing essentially today. So look at that first example here. The first example works with very similar, but it's orange juice, right? So orange juice is sold 1.5 liter cartons in 250 milliliter boxes. A 1.5 liter carton sells for $3.75. So 1.5 liter carton is $3.75. Is that right? Okay. And 10 250 milliliter sells for how much?
$7.39.
$7.39? Thank you. Okay, excellent. All right. Find out what it's going to cost per milliliter. Cost per milliliter here. So I want you to write this down. We're going to do it different than the book. Okay, so find out what the cost is per milliliter of this. Okay, how do I find this out?
Divide 3.75 by 1500.
3.75 divided by, again, converting liters into milliliters. I multiply by 1,000 instead of divide. So I get $3.75. And what does it end up being?
0.0025.
Dollars per milliliter. Okay, good. What about this guy?
7.39
7.39.
divided by 2,500.
Why 2,500?
Because there's 10 of them.
2,500 milliliters. Okay, good. And what does it work out to?
0.00296.
496 per milliliter. So which is the better option here?
So 1.5.
the 1.5 liters warm shoes, right? Okay, simple so far, right? Any questions? Conversions bothering anybody? Pretty straightforward today so far. Okay. The next thing then, if there's no questions with this, the next thing is we want to look at that graph on page 219. It says, describe a scenario that represented in this graph, compare the rates corresponding to each line segment, and discuss why the rates may have changed. Okay. Just by looking at that graph right now, your distance is your y values. Your time is your x values, your horizontal. Okay? What can you tell me that this looks like right now? Tell me what's happening here. Just give me a scenario, any scenario that may be representing, that graph may be representing. What could it be?
Someone walking.
Sure. Where?
To their friends,
Busy,
so
like downtown, busy downtown.
Someone.
Could be. Okay, so what's happening in each section though?
they walk for a bit, they stop.
Where do they stop, Kelly? Which section of that shows me that they stopped?
Where the circle is.
Like which one?
Like B, like A to B, they stop. B to C, or C to D is where they, like, flat stop.
Right, so the circles actually don't. They don't, the dots don't represent where they actually stop. They just change their speed. Okay?
Oh, yeah.
But at C to D, you're right, they do rest. And then where do they end up when it's all said and done? Back at the start. Right? So that this graph represents somebody probably running right away. Right? Then a slow walk, then a stop, and then a constant pace to get back to where they started. Fair enough? Okay. So can we find out then what the pace was in each of those situations? Well, what am I looking for? I'm looking for the speed or the velocity in that case. How do I find speed or velocity?
Distance over time.
Distance over time. So distance over time represents what? Speed or velocity?
Speed.
Speed, right? Now this is irrelevant to most. This is just me throwing out physics stuff. Distance over time. And theoretically, velocity is
Displacement.
displacement over time, which means then I need a direction. Okay, and in this case, I probably will designate a direction, so I'm actually going to look for the velocity in this case. So the velocity, the change in velocity, is equal to your change in your displacement over your change in your time. Well, which axis is the change in displacement?
Y.
It's the y-axis, correct? So what does change mean? Change means I want to take my final minus my initial. So I want to take my final displacement minus my initial displacement. Which in this case, for the axis, if I was to label this using the axis, is actually what?
Y2.
Y2 subtract Y1, correct? Now the time, we do the same thing. Time 2 minus time 1. Well, which axis is that? That's the x-axis, correct? So I'm taking the change over my y-axis over the change in my x-axis, which by definition is actually what on a graph? Slope. Slope is change in y over change in x. So to find out what the velocity is here, I'm going to mark off the coordinates. So the coordinates for A is what? What's the coordinates for A? 0 and 0. What are the coordinates for B? 10 and 30. Okay? So, review our math here. Let's do x1, y1 up here. Let's do x2 and y2 down here. So I want to take my y2, which is what? 30, minus my y1, which is 0, over my x2, which is 10, minus my x1, which is 0. So how fast was he going? 30 over 10, which is 3 over 1, which is 3 meters per second. Okay? From B to C now. What's my coordinates for C? 25 and 40. Okay? So now let's make this guy x2, y2. That? Okay? We'll make B now x1 and y1. So let's find our change in velocity from B to C. So what's my y2? 40. 40? What's my y1? Because I'm using B now. What's my x2?
25.
25 minus 10, which is equal to 10 over 15, which would be, we'll just leave it as, what is it, 2 over 3, so that'd be 0.667 meters per second approximately, right? So in the first part or the second part, was he going faster?
First part.
First part, 3 meters per second. Second part, slower. Third part, the C to D part, how fast was he moving?
0.
0, because he was at rest. Distance didn't change. Time changes, time kept going, but distance didn't change. Okay, and then we can find it from D to E. Okay, what are we going to notice about D to E though?
It's going to be negative.
It's going to be a negative, which means what?
He's going
It's going
Opposite direction.
opposite direction to what we started, right? Sure. Okay, so what is D? What are the coordinates for D?
45 and 40.
45 and 40. So that'll be my x1, y1. And my E,
70 and 0.
70 and 0.
0 and 7.
Change in velocity. Y2 is what? 0. Y1 is 40. X2 is 70. Y2 is, or sorry, X1, I keep doing that. 45. So I've got a negative 40 over
25.
25. Right? Which is what, minus 8 over 5? Meters per second. Okay, so 1.6 meters per second. And the negative in this case shows that I have gone back in the opposite direction to what I started. Okay? Any questions about that? All right, we have approximately 3 weeks, 3 school weeks, so about 15 days, in which to finish up this guy, test on this guy, and then start reviewing for your exam. Okay? Your exam review will consist of, I think there's some cumulative reviews in here, is there not? So we will look at the cumulative reviews, we'll look at your old tests, okay, and go back through them. You will get a, I believe, I'm not 100% sure, but I believe I have a pre-test exam for you to work on as well, which you'll get a couple of 3 days before the exam itself. Okay?
Do we not know when this exam is yet?
We should know by the end of this week. We have a staff meeting tomorrow. So we'll have an idea. Okay, so it's the week of January 30th. It starts that week, and I don't know what the schedule looks like. Other than that, this won't take us long to get through this chapter 8. And you want to make sure that your cheat sheets are well stocked going into that exam. Making sure, because you've got 8 sections, all of those, each corner of that cheat sheet should have a chapter on it and should be up to snuff. Okay? Any questions today? Probably a little tired from the break. Working so hard, I'm sure. So you have 8-1 to do today. You can go through 8.1. If you happen to get finished it, you can go back and do page 216 and 217. But there are quite a few questions on 8.1. 8.2 actually is a carry-on with it, but we won't, I'm not too concerned about it till tomorrow. Okay, so I think we have, what do we have? Only 4 in here? 6. So it'll be, more or less, it'll take us to the end of this week to get finished this unit. And then we'll test likely Tuesday next week and start reviewing after that. Got it? Okay, get at it then.